Okay, so we've learned today a lot on various materials to produce reliable solar modules and the opportunities and challenges associated with them. At this executive panel, we would like to reflect on the content of this event from a somewhat high-level perspective, because I think in these presentations that we had and the following Q&As, we went into it with very in-depth detail. I felt almost like being in my most favorite university classes again, so much I learned. But that's actually what we want here. This event is really about data, data, and not so much about marketing. So we want to reflect on what we do. Just brief introduction, who we have with us today. You see to my next, actually, still with a beard, is Mark Ma, who is the Global Marketing Manager of DuPont Photovoltaic Solutions. Most of you probably know him. He's been around for quite a while. We have with us Jenya Medbray, CEO of PV Evolutions Lab, also a pioneer in solar, a long time around, needs no introduction. Happy to have him dialing in from California, so very, very early. Thanks, Jenya, for joining us at that early time. We have again with us Colin Tran, Vice President at HiUV, and we have with us Dr. Fute Chang, CTO at Jollywood. And last but not least, we have Lars Pudlowski, CEO at Solico, and many of you know him probably as well, because Lars is probably longer in the sector than any of us here. So I feel sometimes old with my 23 years now, but Lars is there somewhat longer. Okay, so what we want to do is I want to give always one short slide, and then we discuss with the panel around the slide. This should be somewhat of a really open discussion, so that means not so much of a sterile Q&A. We want to talk about certain topics we've learned today. All of you are invited to participate, so that means I will look at the panel, at the control panels, to include your questions. I will try to make that way that they fit somewhat into the structure we're discussing, but just feel free to contribute, and then I try to get that in. Can we continue with the slides, Min?
Sure. Okay.
Min? No, Min. Otherwise, watch. Min? Min? Or shall I share my screen? Hello? Okay, yeah. Okay, this one. Let's start with this. Okay, so Jenya was so nice actually that he prepared some slides, and that should lead us a little bit along this 1 hour that we've had. And so while we talked a lot about also the upstream part so far, here I would also at the moment actually start a little bit more downstream. And that means actually very much downstream from the user's side of view. On this slide here from PV Evolution Labs, we see basically a summary of the latest 2020 scorecard, which probably every one of you is familiar with. And one question and one problem is, how does one really, or the customer, select a reliable module? Min, please stay there. And there are, of course, a lot of questions, and Kaushik just mentioned that. I think there has been so much innovation taking place recently in the solar sector that there's so much availability of different products and formats and materials, and it's really not easy actually to kind of make the right choice. We know that certification testing is often insufficient. We talked about that. There are challenges regarding warranties and Genia. So I think that's your bread and butter. So when you are facing these issues that you've described in your 2020 scorecard, what's your advice in this regard if people come to you?
Yeah, thanks for having us here, Michael. Happy to comment on that. So in the scorecard, we are testing modules that are commercially available. Typically, we're hired to do the testing, and that's typically pushed by the large buyers in the US, mostly US, a little bit European markets. And so what this list of different technologies that we've seen is what we've seen submitted to the scorecard in either early 2020 or even 2019, and that has gone through the testing. And you can see there's already a lot of different technologies, 8 different cell sizes, different cell technologies, etc. What we've seen since then is actually an acceleration of different module and cell technologies, including, you know, larger wafers than what we've seen here in the 2020 scorecard, which we now have in testing, which we'll see in the 2021 scorecard. Even different interconnection techniques, different module sizes, especially. We've seen module sizes really go all over the map to quite large modules. I think with JA's 700, 800 watt module probably being the largest. So we've seen quite a large range of innovation in the space. And what we've seen historically is that pretty simple design changes can have pretty significant reliability implications. So something as simple, seemingly trivial as adjusting the cell-to-cell spacing inside of the module can have implications on thermal cycling performance. And when the temperature goes up and goes down, the cells in the glass thermally expand and contract, and the bus bars can generate cracks, and those cracks can propagate, and you have issues with the internal circuitry of the cell. So it seems today that manufacturers are rushing to release newer, higher, latest and greatest technologies pretty fast. The larger manufacturers are doing the right things, it seems, by working with us and working with their own internal labs to perform a lot of testing before releasing things to the market. But I think that's not always going to be the case across the board. So this reliability testing of, you know, different stress sequences that Kaushik talked about earlier for the backsheet, and then other areas as well, I think is absolutely critical before being released. Ideally, you have 5 years of field data. When you have a new module coming out every 6 months, that's obviously not feasible. So the best commercially reasonable thing you can do in a reasonable time frame is subject the modules to a lot of reliability testing. And in the US, third-party reliability testing is required. I would expect that to be everywhere globally, but I think today that's the best thing we know how to do, how to vet new technologies, is put it through things like the PVEL PQP test sequence.
Okay. Mark, so on the one hand, you're very deep upstream. You're supplying a key material to backsheets, but you've been very much advocating reliability forever, actually, at DuPont. So, what's your main message when you look at the customer, actually?
Yeah, sure, Michael. So thanks for giving me this opportunity. You know, we are a material expert and very upstream, as you mentioned, but we always talk to the downstream developers or asset owners. You know, the message we hear from them actually is like, this is a huge investment, and of course the upfront investment is critical, it's important, but more important is the reliability and the safety of their assets over 25 or 30 years. So I think that's a key message for I think the whole value chain of this PV industry to think about. Just imagine if you are a consumer and you have options to buy electricity from different utility companies. One is very cheap, low cost, low price, but they are just not stable. You know, sometimes they have this blackout, and the other one is more stable. Price a little bit higher. You know, I will of course choose the more stable one, and this is also similar to the your cell phone. You always want a stable signal. So that's just want to illustrate how important the long-term reliability it is to the whole industry, and also you know. We believe one of the key fundamental factor for long-term reliability is material, and for you know, for some material, from material perspective, 25 or 30-year lifetime is a very long time. Just imagine, especially in the field, exposed to different aging stresses, outdoor aging stresses. For 10-year lifetime, I would say we might be able to modify some materials by adding some additives to make it extend the lifetime to 10 years. But for 25, 30 years, this is really determined by the intrinsic properties of the material. So if you're trying to modify a material to extend the lifetime, 30-year, 25-year, definitely would be a very stretch. The second point I would like to make, Michael, is you know, these days when you ask people why they believe their module can last 25 or 30 years, you don't always get a very clear answer. It's kind of vague, or they will show you some lab test results, right? And saying, hey, now that's why we have confidence. But the tricky part is the current lab test. A lot of them are not cannot simulate the real outdoor aging mechanism, because based on IEC test, these are all single stress tests, just the UV or just the damp heat. But in the outdoor, you imagine both UV and moisture and this thermal cycling stress and everything is acting at the same time on the material. So that's why one of the key reasons we see this PA, polyamide backsheet cracking so quickly in the field, and also that's why I think both PVAL and NRail they developed this new sequential or combined aging test to simulate this. But this is a key issue for the industry. I think a lot of new technology, let's say, or new material introduces new potential issues, while we don't have a testing method to detect them yet. So that's why we believe, as Kaushik just mentioned, the field data is extremely important. And as Jenya mentioned, 5-year, that would be ideal. I used to work in automotive industry, and for the paint, automotive paint, they need a 5-year Florida exposure test. So, but for PV, for automotive, it's only required 10-year maybe lifetime, but for PV, it requires 25-year lifetime. While we are launching new products faster than iPhone or than telephone industry, right? So this is really, I think, a miss or a mismatch between the downstream needs and also the industry supply chain, the whole supply chain. So the third point, Michael, I want to make is really after so many years in this industry, I start to feel people tend to believe what they want to believe, and you know, when they are launching a new product, they always try to find the data that support their beliefs, well, tend to kind of miss or neglect the data that might against their beliefs. So that's again why we think field data is the most objective data that telling us what works, what not works. And unfortunately, the industry is developing so fast, we don't have a lot of time to collect these field data. So that's why I think PVal's work and also large their consulting these companies are playing at this moment even more critical role to help the downstream customers to select the right product for their projects. Thank you.
Okay. Thanks, Mark. Yeah, that's great. So let's maybe have here the manufacturers from the backsheet and the encapsulation side. Fute, you have just joined, Fute Zhang. Well, are you having also discussions with end customers? Are they coming to you? Usually, you probably talk to module manufacturers, but what are you seeing, and how is this whole reliability topic? How do you see that in your day-to-day business, and how is it actually sometimes in discussions also maybe with bigger EPCs or developers? Are you talking to those guys?
We discussed with EPC. A lot of EPC told us that a lot of modules break during installation process, and China Southern Power Grid find the module operating temperature is lower than double class, so the power output is higher than double class. Jinko Solar realized this could be huge break problem, so they select transparent backsheet module design as their major products. So okay, that's all.
Okay, thanks, Colin. And from your side?
Okay, can you hear me?
Yes, sure. Can you?
Yeah. Okay. Signal a little problem just now. As my idea, I think we do not need to worry about that so much, because I think that currently module technology cannot lasting for 8 or 10 years. It will be changed, for more higher efficiency, around 30% efficiency in future, I think. So I think, of course, we need to do something to, as my idea, I discussed with a lot of the module makers, even some end users in China. They also pay a lot of attention on the material like encapsulant material and backsheet and John box, whatever. They select the suitable quality product inside their binding files to ask the module maker to select the right parts of the raw material. So that's really I think really important part for the end users to focus on the quality issues. And from other packs, I think even we do a lot of certifications and a lot of tests, but that means all the PV modules can be promised to be same quality when they on the real PV power station. I don't think so. It depends on the processing control about a lot of things. It will be not just simply to be evaluated of the whole power plant quality conditions. And from the third part, I don't think it's currently there is any efficient ways we can do some really efficient test and can conduct it to the 25 years durability, you can give that promise. It's not that easy way to have a really happy accelerated testing method to be evaluated that. So I think it's really complex for us. What we can do is, I think we just do a lot of the basic research of the new technology and a new material. Do some comparison. We can select which way is the best. Which way? Maybe it's not that high efficient products. Maybe it's some more, so reliable products or as our test for the comparison. I think that is what we can do currently. Thank you.
Okay, thanks. Lars, you've been working in many different roles. You've been responsible for producing modules at Solon. You've been developing and designing modules at First Solar. You've been, and now you're setting a new venture up, actually, which is at the moment, as I understand, more in module sales. You have to look at exactly what you will pick and what you will use. So first of all, so how do you look at actually all the materials you're choosing? And second, actually also, how do you see certification? Because certification has its limits, but obviously also brings costs and time delays. So, so what's your take on this?
Yeah, hello. Yeah, first of all, let's say start with the certification. Certification is a must. So if you want to sell something, you need these certificates. But what you need to do definitely is testing additionally or beyond certification. And I think what is very important that you do this kind of combined testing so that you don't only make TC, let's say 600 or even 800, or you only make DEMP 2000 or 3000, but there are some kind of scientific reports that some kind of combined test like DEMP plus UV plus HF afterwards, that such kind of combined tests can really significantly increase the stress of the panel and can really bring new insights into failure modes of products. So of course it's some kind of a dilemma that you bring out panels actually after a very short R&D period, but they should last longer and longer. So I'm really glad that there are some kind of scientific investigations on how you can do accelerated stress testing. And I think those kind of combined stress testing is really key. And for me, it is really important to really understand what kind of combinations and what kind of module designs might lead to what kind of failure modes. Yeah, and besides that, I think it's very important that you really, as someone like in our role, so we don't have like own production, but we are contracting companies to produce for us. And of course, it's really important that you understand the chemistry of the raw material. And I think this morning or earlier today, there were really like great presentations here about deep understanding of the raw materials. I really appreciate what all the presenters have told us today, because I think this is really crucial that someone who is in charge of designing products really have a deep understanding of how the raw materials can interact to each other. And I think this is another crucial important point, that you really have experts, technical experts who have a long experience in the industry, who have seen a lot of things also failing and understands why things have failed. And I think this is a second very important point.
Okay, Min, can you maybe just show the next slide? So on next one. No. Yeah, this one. Okay. No. Yeah, this one. Okay. Okay, so take a look at this slide, and I would like to discuss a little bit how to deal with really this innovation pressure. We already touched that upon a little bit. What you see here are 6 modules actually from top 10 module manufacturer. The modules are pretty new. You can see that these are half cell modules, and they went to an ML test. And in the EL pictures, you can simply see that towards the middle, I don't know, there's some bending and there's some cell defects actually. The performance losses you see are not so big, so the maximum is less than 4%. The question is still, do we want to sell something, even if it would be maybe almost still tolerable? Would be the customer really in the end happy? Does he or she want to have such a module product? And especially if we just assume this is just the beginning and the degradation actually might continue. So what are we doing with this? So why are we seeing such things? And this product is just about to go into mass production, as I understood.
Yeah, actually, this is a product which is pretty new, and it comes with something which people call like an innovative solar cell interconnection technology, which means it's not like conventional cell interconnection from the front side of one cell to the rear side of the other cell. It's something different here in order to also mostly increase the power density of the panel. And for me, that is a great example where people have developed something, and maybe even like in pilot production, where the engineers were supervising everything, it turns out to be good, and like some kind like golden samples have been tested successfully as everything is certified. But now it goes into mass production. It's rolled out, I don't know, on maybe 20 manufacturing lines, and it's any kind of this kind of very new technologies maybe have a smaller process windows where there are reliable and good products. So for me, this is a great example of how this innovation pressure might lead to the fact that products go out in mass production to the market too early. And yeah, definitely that's something that as a customer, I don't want to sell. And I think those kind of EL images are beyond any specification. The question is how you can avoid that. And of course, there are like two players. One are the manufacturers, and they need to innovate also in order to reduce the cost. But the other players are the customers, the downstream players that Jenya also were mentioning. They are buying, and I think if they continuously make pressure on the manufacturers, they want products which have higher efficiencies, which are getting cheaper and cheaper. Of course, they make maybe too much pressure on the manufacturers. So I think also it's a little bit, let's say, as a customer, you have to ask yourself, do I have reasonable specification? Do I have like reasonable demands towards the manufacturer? And I think if you always want to buy the cheapest and the newest product, of course, it's difficult to produce something which is the best and the cheapest product at the same time. So I think also as a client, as an end user, you must ask yourself if you really always want to buy the cheapest product.
Yeah, maybe, yeah, Jenya, maybe also if you look at that and all these new technologies that also might bring some challenges, issues. So maybe you can actually kind of give some background on this.
Yeah, sure, happy to. So this is interesting. I'm actually surprised to see these only 2, 3, 4% degrading, because they look pretty bad. And it does look like there is some consistency to the failure pattern, that it's kind of in the 4 quadrants. In the middle of the 4 quadrants of the module, there's perhaps something in the manufacturing process where there's something weak happening there. I think one thing I'll say is there's the age-old disconnect of how panel manufacturers make money and how project owners make money, and that's kilowatt hours, of course. And while these are 2, 3, 4% degraded at STC at 1,000 watts per meter squared at 25 degrees Celsius, I suspect at low light performance, the degradation is probably quite a bit higher. And so a plant owner would likely see higher underperformance than this 2, 3, 4% on an energy basis. And this is exactly the role that third-party testing plays, is trying to bridge the gap between selling watts and having a reliable product that can generate kilowatt hours over time. And I think it's tough when it simply comes down to the price, because every manufacturer that sells really low price still claims and has some data that shows why they're the best and still very reliable, and they cracked some nut that nobody else could and are producing the cheapest modules and the most reliable modules in the world. Of course, we can tell you that we test a lot of the panels from a lot of different manufacturers, and we see quite a range like what is shown here. Not every module manufacturer is tied for first place. There's lots of issues like this. And so from the buyer's perspective, from the developer's perspective, it's difficult to make any kind of assessment on this module is 10% cheaper than this other one, but they have data that shows they're good. You know, who are we to say they're not? So that's, you know, again, why this comprehensive third-party testing is so important. It's impossible to really know that this is going to happen in mechanical load testing unless you actually do the mechanical load testing. This is, yeah, interesting results also, because these cells look completely bypassed. So the interconnect method is certainly novel here, as Lars mentioned.
And what about the whole certification issue? Of course, there's so many complaints about the traditional IEC tests. Of course, they are changed consistently. So what can happen here actually because still everyone is kind of doing that, costs a lot of money, costs a lot of time. So what's the solution for the sector?
So I think it's important to keep in mind what role certification plays in the market. The objective of IEC or UL is not to set a very high bar that only extremely reliable products enter the market. It's actually to set the lowest bar possible that as many manufacturers can enter the market as possible while still maintaining safe products that don't just fail out of the gate, and then allow for market dynamics to define. Maybe there's a role for a lower price module that only lasts 10 years. What a large utility scale plant that's financed by Wells Fargo has maybe is a different level of requirements. So there needs to be market-based mechanisms that set higher bars than certification. Certification is also, the development process is based on international consensus with different stakeholders that have a lot of different interests in the industry. So they're very, very slow moving and take 5 years to have a new iteration of a standard come out. As we've seen in the module space, the module innovation is much faster than that. And we keep getting blindsided by new aging behaviors that nobody predicted, PID and then LETID, and then now who knows, there's so many different flavors coming out. So relying on certification is not wise, obviously, as has been experienced many times over the industry, but I think certification plays an important role, and it does a job. It keeps the very gross design flaws out of the market. And you can see that by looking at the failure rates of certification. The failure rates are not zero. The failure rates are actually quite high in like the certification labs. They see failure rates in the 10+% range. So there's still, or greater. So there's still quite a bit of just errors that enter certification in errors in product design or material selection or process design. So certification plays its role, but it's a minimum bar. Something like PVEL or an equivalent program needs to set a higher bar for institutionally financed projects, where in the US, 35-year useful life is now commonplace.
Okay. So maybe anyone to comment on this topic? Otherwise, maybe next slide. So we've also talked quite a bit today on different flaws and failures. I think this is another slide from the 2020 scorecard, and we still hear that old ghosts are still hunting us, so such as PID, as you can see in this slide. So how can we make sure that sort of such things can be overcome more or less completely? Because we know what the problem is now, and we theoretically know how to do it better, don't we?
I can comment on this real quick for starters, since this is a p-val slide. So each bar here in this chart is one bill of materials that has degraded through PID stress, which is applying negative voltage in a damp heat chamber. And you can see there's many modules that degrade substantially, many modules that perform quite well, and everything in between. I can't tell you how many times I've seen PID free on a data sheet where that's not exactly what we find in the test results. I think the challenge with something like PID is maybe we know how to solve it, but there's typically a trade-off. So we can engineer the silicon nitride coating on the front side of the cell to be very PID stable, and then it won't have the optimal efficiency. So that's a pretty big trade-off when a module factory increases the output by 0.5%. That means their revenue just increased by 0.5%. That's a big deal when margins are not that high in the PV module manufacturing space. PID is perhaps an old, well-known issue today. In the 2020 scorecard, which is the most recent testing we have, we've seen more degradation and failures than we have ever before. So it's clearly not quote unquote solved, but it is understood. So we know how to test for it. But just assuming that it's a well understood aging behavior, manufacturers have it under control is not right.
Maybe I give a quick comment. For me, that's a great example of how like the cost pressure in the industry might lead to let's say to a not perfect development, because as Jenya said, the root cause is known. It's known how to avoid it. You can avoid it on the cell level. You can take like certain encapsulation materials which make products PID safe, but this all costs a little of money. And again, there's this kind of trade between the cheapest product and the best product. And I think if you want to buy the cheapest product, yeah, don't be surprised that it might not be the very best product.
Hey, Michael, I want to make a quick comment also. I think this PID issue has been kind of understood and largely not completely solved though for monofacial cells or modules. But with the bifacial cell, we're seeing a more complicated mechanism. They have both front-side PID and backside PID, and also because the bifacial module are using different passivation technologies, we're also seeing different PID performance with different cell technologies, as well as the encapsulant change from EVA to POE, and now also there's kind of co-extruded EV and POE together. This things all complicated this issue a lot. So we are also trying to better understand some PID issue might be a real issue. Some PID issue might be a lab test only issue. They don't find it in the field. So I think this is a great example to show that with just minor change in technology or in material, we see a much more complicated issue as this module itself is a total package rather than just the one material.
Maybe Colin, I think you've looked so deeply into PID, and maybe for those who didn't listen to your in-depth talk, so just in in a short statement.
Yeah, I agree with what Mark just mentioned. I think the PID issue is really complex. Maybe it's what we see on the screen currently. Maybe it's not just only for the PID problem. It may be a lot of other problem like cruising, whatever, still can cause. It's really a complex problem. Today in my presentation, I gave some classification of the PID, PID shunting, PIDs, and the PID-C, PID crossing. In fact, it's not that happened dividedly. It maybe come together. At beginning, it's PID-P, and later they will became PID-C, and at the final, they will be PID whatever, PID shunting, whatever cannot be recovered. So it's really complex. I think we should evaluate about the new technology, not just for the whole product, just for the final modules. We should investigate deeply. We should evaluate and do some research on the crossing mechanism of the cells and of the grid fingers crossing with the material, with all of the potential induced or some current induced or some light induced. We do a lot of detailed research to evaluate the new technology or ensure their future's performance. Thank you.
Okay, thanks. Fute, you want to comment also?
I agree with Mark. As we all know, during 2014 to 2013 to 2014, new anti-PID technology has been applied to cell productions. After this period, we cannot find much PID issue in field. So I think that a PID issue only find in lab test. Thank you.
Okay, thanks. Okay, next slide, Min. Okay, so let's, so I think again, this is also from the PVL scorecard failures. And I think what we see here is that every fifth eligible, no, please back. Every fifth eligible BOM had at least one failure. And I think that also 1 in 5 manufacturers tested experienced at least one junction box related failure. So how much of a concern are such data to the industry, to all of us? Especially now that solar is really getting big. We're talking now about gigawatts and more gigawatts. We're now at 100. We will be soon at 200, and we will be at some point also at 500 gigawatt levels per year.
Yeah, I mean, I think it's clearly a concern. Manufacturers, as you suggested, are producing 100,000 panels every single day. So one issue gets multiplied very, very quickly across a large number of modules. We've seen widespread recalls in the US market on certain projects don't perform and all the modules are swapped. We've seen that a number of times. I think wet leakage failures in junction boxes are probably a little bit difficult because there's probably installations where they won't ever cause a problem, and there's other installations that we've seen where on wet mornings they have ground faults and the system shuts off, and they're chasing, you know, feeders that are buried underground and inverter issues for years. They get very difficult to chase down where these issues are coming from, especially when they're intermittent. It only happens on wet mornings and not dry afternoons. It's clearly an issue that we see so many junction box failures, and maybe it's further evidence that the innovation is just happening very quickly. I mean, we've also seen lots of different junction box designs, like the small potted one you see in front of you in this picture here. Probably didn't exist a few years ago, where they tended to be much larger junction box. Now they're split, and junction box is one of these things that seems very simple, but still can be a cause of failure over time. Just the leakage going, leakage control, exposure of high voltage conductors to the environment. That's a safety issue. So that is a serious issue that needs to be vetted. Some of the ones where we found failures, the manufacturers came, reviewed everything, agreed with us, updated their module design, and then they passed. So this feedback cycle is very important, and probably, maybe some of them were produced with the issue, but as the sooner you solve the problem, the better.
Yep, Michael, I also agree with Jen. This is a issue that really deeply concern me myself, and I think this will be a big issue for the whole industry, as well as you mentioned. The installation scale is growing so fast these days. Already, I think we're targeting 140, 150 gigawatts next year, and also I want to make a example here. Like 7 years ago, when this the polyamide battery just launched into the market, our test shows it's not going to last 25 years. So we asked the module maker, why you think it can last 25 years? And they said, hey, the lab test shows it performs even better than your Taylor battery. And then after 3 years only, it started to crack. And same, so we also found PVDF and as well Unreal and PVAL, they found in their combined aging test, it's also cracked. But still, there is a lot of module makers are using it right now, and it's hundreds of gigawatts level instead of like AAA or polyamide battery. It is about 10 gigawatts level. So this any issue, it's not going to happen immediately next year, but after 5 years or 10 years, it's going to be a huge issue for the whole industry. Another example, it's like I remember about 4 years ago when glass module just it's a monofacial glass module, and I was asking the module maker, why you think it can last 30 years? So they offer 30-year warranty, right? And they told me because the lab test, the performance is better. So I think later we found this PID issue. We mentioned we also found this frameless glass module sagging and break in the field. So now again, about 1 year ago, people start to introduce this 2mm heat strengthened glass structure, glass module again. So I'll ask the same question, but as I mentioned earlier, the answer is always pretty vague. I think people just try to believe this thing could work for 30 years. And now people are talking about 1.6mm glass can also work, right? So it's really, I think, but also we heard from this testing institute that they start to find more failure in their health test. And also we heard from actually a module recycle company that they recently got a lot of this break the glass modules. So these are definitely, I think, concerns the whole industry should put more thoughts into and be taking a more conservative approach, as this is a 25 or 30 year lifetime product. It's not just a product we are going to replace after 3 years. So yeah, that's my input, Michael.
Maybe Michael, regarding this junction box, maybe one comment from my side is that maybe this is a good example where the product design actually might be good, but the second thing which determines if the product finally is good is the manufacturing quality and the manufacturing consistency. So what we experience specifically with junction boxes, that it might not be a design issue, it might be a manufacturing issue if a junction box finally leads to a failure in the field.
Hey, Michael, I
Also,
think
it's
you
really
are on
about,
mute.
sorry. It's really about quality control also about, because I think there are also millions of junction boxes produced by whoever does them. So I think if there's a little issue, I think you have really a big issue. And even it's only a one-day shift or
yeah, and actually a junction box is really still really a big problem. So we've been involved in a field failure in India where like thousands of junction boxes have been falling off, and that was basically one of the top 3 companies, manufacturing companies.
Okay. Well, but maybe I think we have 8 minutes or so. Maybe the last slide, because I think I want to touch in the end actually one question, because and this is the performance or the warranties we're talking about. So I think here I took one from Jollywood over 30 years. That's for glass. The reason I chose this one is because Jollywood is one of those 2 companies with Jinko of leading companies that is also offering 30-year warranties for glass transparent backsheet products. But the question is here, so how long will this continue? Will we see that more? There were already, I don't know, from NREL, there was some research actually that a module could live 40 years theoretically. How long do warranties need to be? Colin also mentioned, product improvements are so fast actually that in 10 years it might actually even make sense to replace the product, because the efficiencies have so much improved that if you look into your investment, it makes simply more sense to replace the module. Depends of course on the application, but I would like to get a feeling from you. So in which direction you think the industry might be going? Will we see a one fit approach for all, or will we see different things that we're seeing, so that it is also maybe easier for the customer to decide, okay, I want to have maybe a product that lasts only 10 years. It doesn't have such a long warranty, but it might be a bit cheaper, because I haven't seen something like this so far.
Yeah, I think why do we have a 25-year warranty to begin with for the past decade is early 2000s, I think it was Siemens Solar released a 25-year warranty, and then everybody else had to jump on board, because if you want to compete in the market, that's the expectation. Now with glass, some use to justify it, some use something else. As you mentioned with Jollywood, it's N-type. Perhaps there is a certainly lower first-year degradation, possibly lower degradation over time, possibly longer life overall. 30-year, so probably it's just a matter of time before all other manufacturers have to catch up and do 30-year as well. I can tell you in the US market, the plant operators are assuming 35-year useful life, and some are assuming 40-year useful life. Useful life is a little bit different because there are replacements. It's useful life of the entire power plant. So there could be some replacements that happen, you know, in the out years, but it's surprise, surprise, cheaper to finance if you assume a longer life, because, you know, the fuel is free. It's all a CapEx game. The operations and maintenance budgets are fairly low. So the longer your CapEx lasts, the cheaper it is per year. And these are very heavily financially engineered in the US, and it's very easy to put 40 in the Excel spreadsheet and see how that impacts the overall economics, and it's beneficial. And so that's pretty common in the US market nowadays. So frankly, if we look at, you know, history of how we landed on 25, it's probably only a matter of time before everybody follows Jollywood's lead here and gets to 30-year with maybe a 0.4 degradation.
We believe that the longer the better. According to the field test results, 30 years warranty is not a difficulty for 30 years. We can compare with old technology modules and new technology modules in lab test to prove the warranty can be more than 30 years. This is my comment.
Okay. Colin, Lars?
Yeah, I see. Also here for me, it's you see, as the user, as the power plant owners, of course, for them it's maybe good if they can put in their spreadsheet a 40 instead of a 30-year lifetime. But again, here, what is the rationale behind? Is there a reason? Are there really good scientific reasons why a panel can last so long? And for me, these kind of long warranty periods, it's really questionable, because let's say a panel might last like 40 years in moderate climate like we have here in Central Europe. But if you go, let's say, to Indonesia or to Malaysia, it might look totally different where it's hot and humid. So actually, but for me, it's driven really by the market expectation. It's not so much driven by the manufacturer here. The buyers are expecting more and more warranty terms, and that's why the manufacturer are finally saying, okay, if I have any technical indication why I can give it, then I give it, because it sells. Yeah. So really the buyers should question themselves if those kind of super long warranty requirements are reasonable or not.
Okay, so then let's maybe have everyone just a final statement. So what do you think is really, as we go now to even bigger numbers, solar is actually already the largest power generation source in terms of capacity additions every year. So I think we added last year twice as much as wind, more than all fossil fuels and nuclear together. And I think that will continue. So it is only going up. So if we look at reliability, what's the most important topic and issue this our sector has to solve, that we can as smoothly as possible move towards much larger demands?
Yeah, I would say it's balancing the fast pace of innovation with long useful life expectations. So we don't want to slow down innovation, but we also don't want to go so fast that we trip over ourselves. I think the solar industry has been very effective at releasing mostly reliable products, and we have avoided a black eye like I think the wind industry suffered long ago. And I think we need to be diligent to keep that going. We've all benefited from it in seeing these massive growth rates. And so let's hope it continues. I think third-party testing it adds time and it adds cost, but I think it's absolutely critical with this fast pace of innovation.
Yep, I fully agree with Jenya, Michael. I think to me, we can maybe divide this module into two parts. One part is cell, which we welcome this new technologies to improve the cell efficiency. Or just imagine it's like a car. The cell is the engine, and you can use a very powerful engine. But for the packaging materials like encapsulant, glass, and the frame, also backsheet, we as Jenya mentioned, we need a more stringent testing protocol. Like a car, you want to make it safe and reliable. So we want to actually increase the bar of that long lifetime standard, while we can always change a high efficiency cell.
Okay. Thanks, Mark. Lars, maybe?
Yeah, basically, I can only second what Zhenya said. It's that kind of balance between speed of innovation and reliability. And yeah, let's say, in my role as a buyer, I'm really some kind of conservative. So I don't want to make too much pressure on innovation. I'm really preferring something which is proven reliable, and that's, for me at least, that's more important than being too quick and too innovative.
Okay. Coming to manufacturers, maybe Fute?
Okay. First of all, we should ensure the warranty and the quality. Secondly, we have to reduce our COE cost.
Okay, thanks. Colin, final words?
Okay, I still insist on what my idea suggests. We should reorganize the resources from the globalized to focus on the study the mechanism of the modules and the cells performance for reliable durability for long term. Yes, I'm also really happy. It's my first time to join this kind of discussion and presentation. I think through the TaiyangNews, and I think we can give more and the institute and research people to organize them to give some supporting to analyze new technology, new cells, new modules, how to evaluate, how to develop the best way to ensure they can be long-lasting product. I think we can do that kind of things to protect our business, to protect our development healthy of the PV industry. Thank you.
Okay, thanks, Colin. Great. That's actually very helpful feedback also for us. So actually, that's how we understand ourselves. That's why our platforms are for free. Our reports are for free. We want to actually make sure that we deliver, distribute all the knowledge and all the data we can get to as many people in the sector as possible. That's our mission. Thanks for supporting us, in particular to our sponsors, because since we're delivering information for free, we obviously need also someone to finance this business or this activity. And thanks again to the sponsors of this event. Our next event will be beginning of November. It will take in parallel and also in cooperation with CSPV, the biggest Chinese scientific conference. As Colin said, we really try to bring together industry, so manufacturers, but also customers and science and technology. Again, that's our mission. Our newest report, because that was the reason, also the main reason for this conference, on backsheets and encapsulation, is now ready for download. You are invited to do that. You'll find it on TaiyangNews Info Reports. Thanks for staying with us, spending the time with us, all your contributions. Have a nice day or have a nice evening. Thank you. Bye-bye.